By 0217 local time on the 15th of July 2026, a Russian coastal patrol officer standing watch aboard the Raptor-class boat P-354 saw something on the water that did not fit any pattern he had been trained to recognize. Not a wake, not a vessel silhouette. Something low, something fast, something that was already inside the strait. He had approximately 9 seconds to act. The Kerch Strait is 3 kilometers wide at its narrowest point, 3 kilometers of black water between the Crimean shore and the Russian mainland, with the Kerch Bridge overhead carrying the road and rail lifeline that feeds the entire occupation. Russian naval planners had spent 4 years treating this corridor as a sanctuary. The open Black Sea was contested, the Sea of Azov was a rear area, and the strait between them, narrow, monitored, ringed with patrol craft and radar posts, was supposed to be impenetrable to Ukrainian surface drones. Supposed to be. On the night of July 14th into 15th, that assumption died in 11 minutes. 4 Russian vessels were struck inside the Kerch Strait before the sky had fully lightened. 1 went down on camera, but the vessel count is not the most important thing that happened that night. What matters, what changes the strategic calculus of this entire war, is the system that led the strike package inside. A drone that Ukraine has been quietly developing for months. A drone that was not firing the warheads itself. A drone whose job was something far more unsettling for Russian naval planners. Stay with this, because by the time we reach the moment the first warhead detonated, you will understand why Russian admirals are now looking at the Kerch Strait and seeing not a fortress, but a corridor they no longer control. Let's build it from the beginning. The Kerch Strait sits at the junction of 2 Russian strategic theaters. To the west, the Black Sea Fleet, or what remains of it, has been battered back to Novorossiysk and dispersed across minor ports after years of Ukrainian drone and missile pressure. To the east, the Sea of Azov, Russia's shallow inland sea, where the remaining logistical nodes feed occupied Zaporizhia and Kherson oblasts by barge. The only surface connection between these 2 theaters runs through the Kerch Strait, under the Kerch Bridge. Lose the ability to move freely through that strait, and Russia's 2 maritime zones become isolated from each other. Supplies that used to flow by sea must travel overland, over roads that Ukrainian long-range systems are already watching. The strait is not symbolic. It is a logistics choke point in the most literal sense, and Russia has treated it accordingly. Radar posts line both shores. Raptor-class patrol boats, aluminum-hulled fast craft running at up to 50 knots, armed with 14.5mm heavy machine guns, have maintained continuous presence in rotation since 2022. The Russian aerospace forces maintain surveillance coverage through a combination of ground radar and periodic aerial patrol. An acoustic sensor network, including mobile penicillin counter-battery systems repurposed for shoreline detection, reportedly monitors the water surface for incoming contacts. And the strait's narrow geometry itself was considered a defense. At 3 kilometers wide, any surface drone attempting entry would be detected and engaged long before it could threaten a vessel inside. That logic held, until Ukraine changed the first element of the problem. The Barracuda is not a strike drone. That distinction matters enormously, and it is the detail that most early reporting missed. Ukraine's Unmanned Systems Forces, the dedicated military branch established in 2024 to integrate drone warfare at operational scale, had been developing the Barracuda as what Western analysts would call a shepherd drone, or more formally, a mission lead unit. Its job is not to carry a warhead, its job is to go in first. Ukraine has not released full technical specifications for the Barracuda, which is standard operational security for an active weapons system. What open-source reporting and OSINT analysts have pieced together from observed deployments suggests a sea surface drone roughly 6 meters in length, running on a low-profile hull designed to minimize radar cross-section. Unlike the Magura V5, Ukraine's primary strike USV, which carries an estimated 300-kilogram explosive payload, and has been responsible for the most publicized naval strikes of the war, the Barracuda carries sensors and communication relay equipment. Its payload is information. Its weapon is the network it creates. The Magura V5 is itself already a proven system. Ukraine's naval drone operators first demonstrated the Magura's capability in late 2023 when a strike sank the Russian landing ship Raptor-class in Feodosia Harbor. Since then, Magura variants have contributed to the destruction of multiple Black Sea Fleet vessels, including the patrol ship Sergei Kotov, struck in March 2024. The Magura runs at approximately 42 knots and carries a shaped charge warhead optimized for hull penetration below the waterline. It is effective. It is also a single vector, one drone, one target, one approach path that Russian radar and patrol systems have spent 2 years learning to recognize. The Barracuda changes the geometry of that problem. On the evening of July 14th, according to Ukrainian Unmanned Systems Forces reporting, confirmed by satellite imagery analysis from multiple independent OSINT accounts, a Barracuda-class lead drone entered the northwestern approach to the Kerch Strait ahead of 3 Magura variant strike drones. The formation spread across approximately 800 meters of water. The Barracuda ran point, closer to the Russian patrol presence, lower in radar signature, feeding sensor data to the trailing strike units and through them to operators likely positioned in a command node well away from the engagement zone. What the Barracuda was doing, in technical terms, is called forward target designation. It was painting the picture. The Maguras behind it were reading that picture and adjusting their approach vectors in near real time. The Russian watch officer aboard P-354, who first detected an anomalous contact at 0217, was not seeing the Barracuda. He was seeing a ghost, a partial radar return, intermittent, too small to classify with confidence. The Raptor-class patrol boats carry a small navigation radar suite, adequate for collision avoidance and basic surface search. They are not equipped for the kind of low observable target discrimination that would be required to reliably detect a vessel with a radar cross-section optimized for evasion. The officer logged the contact, he radioed the shore station, he waited for clarification. He waited approximately 40 seconds. At 0218, the shore radar post at the Crimean side of the strait, operating what Ukrainian military analysts have described as a Monolith B coastal surveillance radar, a Soviet-era system with modernization packages applied at unknown depth, picked up multiple contacts simultaneously. Not one anomalous return, several, spread across the width of the approach channel. The duty controller at the shore station now faced a classification problem that his equipment was not designed to resolve in real time. Were these surface contacts, wave returns, or the leading edge of a coordinated drone attack? The Monolith B system has a maximum surface detection range of roughly 250 kilometers against conventional vessels. Against low observable surface drones running at wave-top height, its effective detection range is dramatically reduced. Independent analysts estimate practical detection of Magura-class drones at somewhere between 3 and 8 kilometers under typical Black Sea conditions, depending on sea state and the drone's approach angle. At 0218, the contacts the controller was seeing were already well inside that reduced detection envelope. The system had found them late. The controller initiated the alert sequence. Russian Raptor boats in the area were ordered to intercept. The shore-based weapon station, a 30mm AK-630 close-in weapon system mounted on a fixed emplacement on the Crimean shore, was brought to active readiness. And for 37 seconds, nothing fired, because no one had a confirmed target solution. 37 seconds. At 42 knots, a Magura V5 covers approximately 800 meters in those 37 seconds. It was the Barracuda that bought those seconds. The lead drone, running its sensor pass and staying between the Russian patrol assets and the trailing strike units, had complicated the picture enough that the defender's response cycle could not close before the strike package was already inside effective warhead range. The first detonation occurred at 0219. Ukraine's Unmanned Systems Forces stated that the initial warhead impacted one of the Raptor-class patrol boats, the P-354, the same vessel whose watch officer had first logged the anomalous contact 2 minutes earlier. The Magura variant targeting fast patrol craft in this kind of strike package carries a warhead configured for maximum hull damage in the forward section, optimized to flood the forward compartment and compromise the vessel's ability to accelerate away or bring its weapon systems to bear. According to Ukrainian reporting, P-354 began taking on water immediately. It did not sink in the strait. It was beached on the Crimean shore by its crew, which, given what followed in the next 9 minutes, may have saved their lives. 4 seconds after the first detonation, the AK-630 emplacement on the Crimean shore opened fire. The AK-630 is a Gatling-type rapid-fire cannon capable of firing up to 5,000 rounds per minute of 30mm ammunition. It is the same type of system Russia uses aboard its larger warships for close-in defense against incoming missiles and drones. Against a Magura running at wave height, it is theoretically capable of an intercept, but the system requires a stable track, and at 0219, with multiple contacts in the water and one detonation already clouding the radar picture with spray and thermal bloom, the AK-630 crew was firing at a degraded picture. They fired for approximately 12 seconds. Then they stopped. One of the trailing Maguras had altered course. This is the detail that separates what happened in the Kerch Strait on July 15th from previous Ukrainian naval drone operations. Earlier strikes, the Sevastopol harbor attack, the Novorossiysk operations, relied on pre-planned routing and operator guidance from remote positions. The drones followed a course. What OSINT analysts observing the July 15th strike noted, based on the tracked approach vectors of the 3 Magura units, was course deviation mid-engagement. One of the trailing Maguras adjusted its approach by approximately 30 degrees after the AK-630 opened fire, moving to place the burning P-354 between itself and the gun emplacement. It used the damaged vessel as cover. Whether that adjustment was operator-commanded or the product of autonomous navigation logic reacting to the changed threat picture is not publicly confirmed. Ukraine has not released the full operational parameters of the Barracuda's sensor sharing and command relay architecture. What is visible in the drone footage that Ukraine's military subsequently released, footage apparently captured by the Barracuda itself from its forward position, is a Magura changing course in the middle of the strait while the AK-630 tracers pass behind it. The gun emplacement did not reacquire. At 0221, the second detonation. This one struck a support barge, a flat-hulled logistics vessel of roughly 500 tons, type consistent with the Duba-class barges Russia uses for interstrait cargo transfer. Satellite imagery reviewed by independent analysts the following morning showed the barge listing heavily to starboard and on fire along its full length. The fire was still burning 8 hours later. At 0223, 2 minutes after the second detonation, the third and fourth impacts occurred within approximately 40 seconds of each other. Ukraine reported both as hits on vessels, one a second Raptor-class patrol boat that had moved to intercept and come within Magura engagement range, and one on a second support barge of similar class to the first. Russia's defense ministry, in a brief acknowledgement released early on July 15th, confirmed damage to several vessels in the Kerch area and attributed the attack to Ukrainian naval drones, without specifying the number or type of vessels affected. It was one of the most direct Russian official confirmations of a maritime drone strike since the Moskva. By 0228, the strait was quiet. 11 minutes had elapsed since the first anomalous radar contact. 4 vessels had been struck. The Barracuda, having completed its shepherd function, was recovered, or, depending on which OSINT source you read, self-navigated to a recovery point off the Ukrainian-controlled coast. Its physical fate in this specific operation has not been confirmed publicly. What was confirmed, by satellite imagery and by the video footage Ukraine released the following morning, was fire, 2 barges burning in the strait, a Raptor beached on the Crimean shore, a second patrol boat visible listing in the water near the Kerch Bridge approach. Here is what that means for the war, and why the Russian Azov Black Sea logistics chain is now under a pressure it has not faced before. The Kerch Strait processes an estimated 200 to 300 cargo movements per month in support of Russian occupation logistics, fuel, ammunition, construction material for fortification, food and equipment for the forces holding the southern front. Some of this traffic has already shifted to road and rail via the Kerch Bridge since Ukrainian missile and drone strikes on Crimean ports reduced confidence in harbor operations at Sevastopol. The bridge itself survived a Ukrainian strike in 2022 and a second incident in 2023 and has been repaired both times, though at reduced capacity for a period after each event. Russia has no alternative surface maritime route between the Black Sea and Azov that does not pass through the strait. What the July 15th strike demonstrated is that the patrol and sensor network Russia had assembled to protect the strait is not adequate to stop a coordinated multi-platform autonomous attack, and specifically that the Shepherd drone concept defeats the response time mathematics that Russian defenders had been counting on. Previous USV attacks had to travel from well outside the strait to their targets, giving defenders a longer detection window. A formation led by a Barracuda-class scout can compress that window dramatically by pre-designating targets and coordinating approach vectors before the strike units are within effective detection range. Russia's available response options are narrow. Deploying heavier surface combatants into the strait increases the target set rather than reducing the threat. Mining the approaches risks the same logistical corridor Russia depends on. The AK-630 emplacements have now demonstrated they cannot reliably intercept a maneuvering target when the radar picture is degraded by a simultaneous detonation. And the deeper problem, the one Russian naval planners are now sitting with, is that the Barracuda is a platform that can be scaled. Ukraine is not operating one of these systems. It is testing an operational concept that, if it holds, can be applied with updated versions carrying different sensor payloads, running different mission profiles, leading different compositions of strike units. Ukraine's Unmanned Systems Forces have now conducted coordinated multi-platform autonomous naval operations in the Black Sea, in Crimean harbor approaches, in open water, and now inside the Kerch Strait itself. Each environment has been a test bed. Each operation has generated data. The July 15th strike is not just a tactical event. It is a proof of concept for a class of warfare that no navy had operated at this scale before, and Ukraine is writing the doctrine in real time. Watch the Sea of Azov in the coming weeks. Russian logistical movement through the strait will tell you whether Moscow calculates this as a sustainable threat or a one-time success. If barge traffic slows, if the Raptor patrol rotation changes, if Russia begins moving radar equipment to elevated positions on both shores, those are the signs that the July 15th operation changed Russian operational planning at the strait. And if it did, then the supply math for the southern front changes with it. There is one more thread to pull: the Kerch Bridge. It has survived, but the bridge's road and rail capacity is finite, and the logistics that used to move by water now compete for space on that structure. Every strike that degrades maritime throughput in the strait pushes more cargo onto the bridge, and the bridge is already a known target. Ukraine has struck it before. The July 15th operation did not hit the bridge, but it tightened the noose around it in a way that targeting the structure directly would not have achieved. That is the geometry. That is what is underneath the headline. If you want to understand this war as it unfolds, not the noise, the strategy underneath the headlines, subscribe to this channel and turn on notifications so you are there the moment the next chapter breaks. Hit the bell. And one final note for the record: this report is news analysis and reconstruction of ongoing, fast-moving events built on reporting from major outlets, Ukrainian military statements, and open-source intelligence grounded in the facts as they are known at the time of writing. As the situation develops, details will change. Stay sharp, stay informed, and we will see you in the next one.